Now let's deep dive into some of the terminologies related to the PWM signals to measure them. There are mainly three terminologies related to it. First is the time period. Time period is total time of a PWM signal to complete its one pulse. Here by one pulse we mean a signal which is having a single high voltage and a low voltage. So total time taken to complete to have a one high and low voltage signal is just a single high and low voltage signal. That is the one pulse. So total time taken for this one pulse is named as time period. And how time period is calculated is, let's say we have a var counter who starts from 0 to the max counter value, and max counter value we have put as 1000, and for each increment of var counter from 1 to 2, 2 to 3, 3 to 4, it takes 1 milliseconds. So total time to count from 0 to 1000 value will be 1 milliseconds into 1000, and that comes out to be 1 second. And only in the transition of var counter from 0 to max counter value we are gonna have both high and low voltage signals. So this is time period, a time taken for var counter to reach from its values, initialization value of 0 to the max counter value, and that is termed as time period. The next parameter is the frequency. Frequency is number of PWM pulses in 1 second. So frequency is calculated by first determining how much time it takes for a one PWM signal to complete, and that is basically the time period that we have just analyzed. The time period is the total time taken for a one pulse to get complete, and then we divide this time period value by the 1 so as to get the frequency, so as to get how many pulses would be there in 1 second. And faster the frequency is, more the frequency is, it means more than faster the high to low and low to high signal switching is happening. We measure the frequency in the unit of hertz, and we measure the time period in the unit of seconds, milliseconds, microseconds or nanoseconds. Then the third parameter which comes is the duty cycle, and duty cycle is the percentage of total time period for which signal is kept on. So more will be the duty cycle, it means the power delivered to the external device would be more. Why? Because in a single time, in a single pulse, high for most of the time that there is high voltage signal. That is why duty cycle is more. Less will be the duty cycle, meaning signal is having low voltage signal for most of the time, so less power would be delivered to the external device. We generally measure the duty cycle in the terms of percentage, 50% duty cycle, 60% duty cycle, where this percentage denotes how much time or how much percentage of the time our signal is being kept on.